Hi, my name is Jeff Davies and I'm a member of the Oracle Cloud Infrastructure team. This is the second of a two-part video series on OCI. In this video, we will take a look at the inside of a virtual cloud network, what they contain, and how you can configure them. Let's pick one of these VCNs, all of which may be very different from one another, and see how a VCN looks from the inside. Before we can go into the details of a VCN, it is necessary to understand a core concept of VCNs, subnets, and networking in general, CIDR blocks. CIDR stands for Classless Interdomain Routing. In plain language, it is a notation for defining contiguous ranges of IP addresses. Every VCN has a CIDR block that defines its network address space, and so does every subnet. This is an example CIDR block. This is an IPv4 example, but the same principles also apply to the IPv6 addresses. Each number between the periods and before the slash indicates a part of the overall IP address in base 10 numbers. Each part is really an 8-bit number ranging from 0 to 255 or 0 to FF in hexadecimal. So the decimal number 192 is represented as C0, as you can see here. The number after the slash tells you how many significant bits there are in the address space. So 192.168.0.0/16 means only the first 2 bytes of the IP address are significant. The second 2 bytes, or second 16 bits, which is ff.ff or 65,535, are available for use, with some restrictions that I'll go into later. Inside of this address space, we can now create a subnet. For example, 192.168.1.0/24. Since there are only 32 bits in an IPv4 address and we are reserving the first 24 to define the subnet, that means that the subnet has 8 bits of addresses, or 256 possible addresses. This means that a VCN with a CIDR block of 192.168.0.0/16 could have up to 256 subnets, each of which in turn could possess 256 IP addresses for use by compute instances, load balancers, etc. Of course, you don't have to use all of the available IP addresses in a CIDR block. They just carve out address space for you to use when needed. Naturally, when you create a subnet in a VCN, its CIDR block must be wholly contained by the CIDR block of the VCN. Remember those restrictions I alluded to earlier when it came to reserved IP use? The CIDR block for the VCN doesn't use any IP addresses at all. It simply defines the network address space that is available for subnets to use. Consider a VCN with a CIDR block of 10.0.0.0/16. A subnet of 10.0.0.0/24 will reserve IP addresses from 10.0.0.0 to 10.0.0.255. However, each subnet uses 3 IP addresses in its CIDR block for internal use, and those IP addresses are not available for use by your compute instances, load balancers, etc. The first 2 IP addresses and the last IP address in the subnet are reserved for networking service. Therefore, addresses 10.0.0.0, 10.0.0.1, and 10.0.0.255 cannot be used by you. The remaining network addresses of 10.0.0.2 through 10.0.0.254 are available for you to use. That's it for the very basics of CIDR blocks. Now we can really take a look inside of the VCN itself. When I think of a VCN, I think of an entirely virtual environment. Something like the holodeck or the construct from your favorite sci-fi show. Things can be created, moved, removed, or reshaped at will. Everything within the VCN space has an IP address that fits in the CIDR block for the VCN. Every VCN has built-in capabilities that you can use. A VCN can be connected to a variety of other things. These external connections are called gateways, and I think of them like doorways on the edge of your VCN space. Each of these gateways are specialized in nature. The first one is a local peering gateway, or LPG. The LPG is used to connect to other VCNs within the same region. You can connect VCNs to work collaboratively to solve business problems and maintain the principles of separation of concerns at the same time. Next is a dynamic routing gateway, or DRG. You use a DRG to connect your VCN to a VCN in a different region. This is often used for disaster recovery. You also use a DRG when connecting your VCN to your on-prem systems. When you connect your on-prem systems, you will do so using either an IPsec VPN connection or Fast Connect. The Internet Gateway connects your VCN to incoming Internet traffic. If your VCN is hosting web servers, you will use an Internet Gateway to allow web traffic into and out of your VCN. A service gateway enables subnet resources without public IP addresses to privately access Oracle services. The Oracle Services Network is a conceptual network in Oracle Cloud infrastructure. These services have public IP addresses that you typically reach over the Internet. However, you can also access Oracle Services Network without traffic going over the Internet. A network address translation gateway gives your VCN and its private subnets outbound access to the Internet. The NAT gateway has a public IP to make the Internet connection on behalf of your assets in a private subnet and take care of all the network address translation to route responses back to the correct subnet and private IP address. Just look at all those network messages busily coming through the various gateways and then going to their destinations. But what are those destinations? Their destinations are always subnets. Earlier, you learned about CIDR blocks and how they are used to configure continuous blocks of IP addresses. Each subnet that you define also has a CIDR block with an IP range that must fit within the CIDR block of the parent VCN. Naturally, subnet CIDR blocks cannot overlap with any CIDR blocks defined by any other subnets in the VCN. Each subnet is associated with a single route table. Route tables define the rules for routing traffic from the subnet to each of these gateways and vice versa. There is always a default route table in a VCN that cannot be deleted. You will commonly define routing rules in the default route table. However, you can define additional route tables with routing rules that are specific to a subnet if needed. Right now, the routing rules are invisible. Let's make them visible so you can see them clearly. Here you can see that there is a single routing rule directing traffic from the Internet Gateway to the public subnet. If we take a look at the route table for the private subnet, we will see that it has many more routing rules. Security lists are lists of rules covering the ingress and egress rules of network traffic for each subnet. Like the default route table defined for a VCN, there is also a default security list. However, a subnet may have multiple security lists, and each security list may be used by any number of subnets. This allows you to treat security lists in a granular fashion for applying security rules. I like to think of a security list as an electric fence or force field between the subnet and the gateways. As long as the network packets meet the requirements of security lists, they pass through unaffected. However, if network traffic does not meet the security list rules and requirements, it is simply vaporized from existence. That covers the basics of VCNs. Now let's dive a little deeper into what goes on inside of a subnet. While subnets and their component parts are still virtual, they also become a little more recognizable as things you might find in the real world. For example, you can create compute instances inside of your subnet. A compute instance is essentially a virtual server. You might create a compute instance to run a web server, for example. As you scale up your web server capacity by adding additional compute instances configured as web servers, you will also want to add a load balancer to balance the web traffic demand between the instances. As network packets are received from the Internet Gateway, they are routed to the load balancer based on its public IP address, and the load balancer in turn routes the packets to the appropriate compute instance. The collection of compute instances that a load balancer uses are called a backend set. Your subnets can also contain block volume storage devices to allow your compute instances to store data. You can also add object storage to store unstructured data. Object storage is a regional service and not tied to any specific compute instance, subnet, or availability domain, so it is available to all compute instances within the region. File storage is actually a VCN level asset and is accessible anywhere from within the VCN. In addition, using a service gateway, you can access file storage located in other VCNs. Not everything is defined inside of a subnet, but your subnet assets will have access to many other OCI assets through the service gateway. For example, MySQL databases are defined at the region or availability domain level, but can be accessed from most compute instances, load balancers, and TCP clients. NoSQL databases, autonomous data warehouses, autonomous transaction processing, and more are also available through these service gateways. There is so much more that we simply didn't have time to go into. For example, autoscaling your compute instances, monitoring, logging, access management, analytics, VMware software-defined data centers, the list was on. OCI is a mature, robust, and complete cloud implementation that will meet your current needs and allow you to grow into the future. That concludes part 2 of this 2-part video series. I hope you enjoyed the videos and came away with a greater understanding of how Oracle Cloud Infrastructure works. Thanks for watching.